So this Linux is a specialized Linux distribution aimed at security professionals. As such, it contains several non-standard features. The default installation ships with several services pre-installed such as SSH, HTTP, and MySQL. etc. Constantly, these services would load a boot time, and which would result in Linux exposing several open ports by default, something sometimes we want to avoid for the security reasons. Uh, so which deals with the issue by updating its settings and prevent the network services from starting at a boot time. It also contains a mechanism to both whitelist and blacklist various services. The following section will discuss some of these services as well as how to operate and manage them. The SSH service or the SL service is most commonly used to remotely access a computer using a secure encrypted protocol. The SSH services is TCP based and listens to a default port on 22. To start the SSH service in Linux, we run systemctl with the start option followed by the service name. When the command is complete successfully, it does not return any output, but we can verify the SSH service is running and listening on the port 22 using the ss command and piping the output into the grep to search the output for the SSHD. If you want to have the SSH service start automatically at the boot time, we simply enable it using the systemctl command. However, be sure to change the default password first. HTTP service. The Apache service is often used during a penetration test, either for hosting a site or providing a platform for downloading files to a victim machine. The HTTP service is based TCP and listens on default port 80. To start the HTTP service in Linux, we use the systemctl as we did when using the SSH, replacing the service name with Apache 2. To have the HTTP service start at boot time, much like SSH service, we need to explicitly enable it with the systemctl. As with the previously SSH service, we can verify that the HTTP service is running and listening on TCP port 80 with the ss and the grep command. Most services in Linux are operated in much the same way as the SSH and HTTP through their services or init scripts. To see a table of all available services, run on systemctl with the list unit file option. Information regarding apt packages is cached locally to speed up any sort of operation that involves querying the apt database. Therefore, it is always good practice to update the list of available packages, including the information related to the versions and descriptions. For example, we can do this with the atp update command as follows. After the ATP database has been updated, we can upgrade the installed packages and the core systems to the latest versions using the apt upgrade command. I'm not going to upgrade right now as it takes a lot of time. So take your tea and coffee before upgrading. In order to upgrade a single package, add the package name after the apt upgrade. A command such as apt upgrade metasploit framework. While you can use sudo command, I haven't given in this scenario. The apt cache search command displays much of the information stored in the internal cached packages database. For example, let's say we would like to install the pure FTP application via the apt. First, we have to do this to find out whether or not the application is present in this Linux repositories. To do so, we would proceed by passing the search term in the command line. The output above indicates that the application is present in the repository. Interestingly enough, the resource agent package is showing up in our search even though its name does not contain the pure FTP keyword. The reason behind this is the APC cache search looks for the request keyword in the package description rather than the package name itself. To confirm that the resource agent's package description really contains the pure FTP keywords, pass the package name to the apt show. The apt remove purge command completely removes the package from the Linux. It is important to note that the removing a package with atp remove removes all the package data, but it leaves usually a small modified user configuration files behind. In case of removal with accidental, adding the purge command removes all the leftovers. dpkg is a core tool used to install a package either directly or indirectly through ATP. It is also preferred to use this tool when the operating system is offline, since it does not require the internet connection. Note that dpkg will not install any dependencies of that package might require to install. A package with dpkg provide the /i or /s install option and the path of the .deb package, the deb. This assures that the deb file of the package to install has been previously downloaded or obtained it from some other source. The bash environment. When opening a terminal window, a new bash process which has its own environment variables is initialized. These variables are from the Grover storage or various settings inherited by any application that they run during the terminal session. One of the most commonly referred environment variables is path, which is column separated list of directory paths, and the bash will search through whenever a command is run without a full path. We can view the contents of a given environment variable with the echo command used by the dollar character and an environment variable name. For example, let's take a look at the contents of the path environment variable. Some of the other useful environment variables include user, pwd, and home, which holds the values of the current terminal username and the present working directory, and the home directory representatively. An environment variable can be defined with the export command. For example, if we are scanning a target and don't want to type the system's IP address repeatedly, we can quickly assign it to the environment variable and use it as instead. The export command makes the variable accessible to any subprocess we might spawn from our current bash instance. If we set an environment variable without export, it will be only available in our current shell. If we use the $$ variable, it will display the process ID of our current shell. The bash environment is an sh compatible shell that allows us to run complex commands and performs different tasks from a terminal window. It incorporates useful features from both Korn shell ksh and the C shell csh. There are many other environment variables defined by the Linux. We can view these by running env at the command line. We can use the tab key in the Linux that will complete our commands or what we are meant by it. For example, if I use the ls command and use the tab key after that, it will show me the list of directories that I might go in. If I type in lsd, it will only show me desktop documents and downloads that I might use in my command. Bash history tracks. While working on a penetration test, it is important to keep a record of commands that have been entered into the shell. Fortunately, Bash maintains a history of commands that have been entered, which can be displayed with the history command. Previously, we used echo to display uh, our output on the terminal screen. This is convenient most of the time, but we can use this command to actually save the output to a file to keep it for the future reference or manipulation. As it shows, if we redirect the output to a non-existent file, the file will be created automatically. However, if you save the output to a file that already exists, the file content will be replaced. Be careful with the direction. There is no undo function for this. To append additional data into an existing file, use As you may have guessed, we can use this operator to send data to the other way. In the following example, we can redirect the vc command, the stdins, which data originally directs from the file we generated in the previous section, and we will try this vc/m, which actually counts the characters of the file. Continuing with the command wc, let's have a look at how to redirect the output from one command into another input of another. Consider this example. Grep searches text files with the occurrence of the given regular expression, the output of any line containing a match of the standard output, which is usually the terminal screen. Some of the most common used switches include /r to recursively search or /I to ignore the test case. Consider the following example. Sed is a powerful stream editor. It is also very complex, so we will only briefly scratch it to the surface. And at the very highest level, the Sed performs text editing on a stream of text, either on the set of specific files or standard output. Let's look into this. The cut command is simple but often comes in quite hardly. It is used to extract a section of text from a line or output. Some of the most commonly used switches include /f for the field number, and we're cutting, and /d for the delimiter. In this scenario, we echoed a line of text and piped it into a cut command to extract the second field using a comma. As the field delimiter, the same command can be used with the line in the text files as shown, where a list of users is extracted from etc password by using the two colons as a delimiter and the retrieving of the first field. AWK is a programming language designed for text processing and is typically used for the data extraction and reporting tool. It is also extremely powerful and can be quite complex, so we will only scratch the surface area as a common use. With awk, we use a switch /f in capital, which is a field separator, and the print command, which outputs the result text. So we see here is an Apache HTTP server log that contains evidence of an attack. Our task is to use bash commands to inspect the file and discover various pieces of information such as who the attacker were and what exactly happened on that server. So we will unzip our file and then we are going to rename our file with the access.txt. So I'm just going to move the access log to the access.log file, and so first we will use the head and wc command to take a quick peek of the log file to understand the structure. And the head command displays the first 10 lines of the file. The wc command along with the /l option displays the total number of lines in the file. We will begin by searching through the HTTP requests made by the server for all the IP addresses recorded in this log file. We'll do this by piping out the cat command into the cut and sort commands. This may give us a clue about the number of potential attackers we will need to deal with. We'll see less than 10 IP addresses were found in the log file, although this still doesn't tell us anything about the attacker. Next, we will use the unique and sort to show unique files, further refine our output and sort the data by the number of times each IP address accessed our server. The /c option of the unique will prefix the output line with the number of occurrences. A few IP addresses stand out, but we will focus on the addresses that has the highest access frequency first to filter out the 208.68.234.99 address to display and count the resources that were being requested by the IP and were used in the following sequences. For this output, it seems that the IP address was accessing the /admin directory exclusively. Let's inspect this further. Apparently, this IP address has been involved in the brute force HTTP brute force attack on this web server. Next, we'll take a look at the file editing in the command shell environment. This is extremely important for the Linux skill, especially during penetration tests. If you happen to access the Unix like OS, although there are text editors like Gedit, LeafPad that might be more visually appealing due to their graphical user interface. We focus on text-based terminal editors, which are both for the speed and versatility. Everyone seems to have a preference with it when it comes to the text editors. We will cover the basic usage for two most common options, Nano and VI. Now to save our file which is edited, we just had to press Ctrl X and our file gets saved. But now I'm going to show it to you again. So if we see our file cat read redirection text.txt. So now I'm going to edit it again by Nano, and once you have added your lines in the Nano editor, you're going to press Ctrl X and then just enter, and your file will be saved. We will look at another text editor, which is the VI, and you can also simply access it with typing VI into your command shell, and you'll get this interface. So to disable the insert mode, go back to the command mode, press escape key. While in command mode, use double D to delete the current line and double Y to copy the current line, and P to paste the clipboard contents, X to delete the current character, and W to write the current file to the disk and say stay in VI. Q and exclamation to quit without writing the file to the disk, and finally WQ to save the file and quit. Background processes. The quickest way to background a process is to append an ampersand to the end of the command and send it to the background immediately after it starts. So let's try this in this example. I'm going to ping /c400 on my local host with the ping results text file. After my commands tries to execute, it will be backgrounded, and I'll get my background process ID on my screen. But what happens if we have forgotten to append the ampersand at the end of our command? The command would have run in the foreground. We could be forced to either cancel the command and wait until the command finishes, regain control of the terminal. The other option to suspend the job is Ctrl Z after it is already started. Once the job has been suspended, we can resume it in the background by using the BG command. The built-in jobs utility lists the jobs that are running in the current terminal session, while FG returns a job to the background. These commands are shown in this example. Next, we will talk about the process control, PS and kill, one of the most useful commands to monitor processes, and mostly by any Unix-like operating system in PS. And unlike the jobs command, PS lists processes system-wide, not only the current terminal session. Now we're trying to find our Pluma editor application in this massive listing. Is definitely not easy, but since we know the application name we are looking for, we can replace the /e switch with the /c with a selection. And I think I have to start my application before going to search it. So now we get our result and the PID of our Pluma, and we can simply kill this process by typing in kill and the PID of the process, and you can see my Pluma editor is also closed. So let's talk about file and command monitoring. Tail is the most commonly used to monitor the log files entries as they have been written. For example, we may want to monitor an Apache logs if we want to see a web server being used. The /f option is very useful as it consistently updates the output as the target file grows. Another convenient switch is /nx, which outputs the last x number of lines instead of the default value of 10. The watch command is used to run a designated command at regular intervals. By default, it runs on every 2 seconds, but we can specify different interval by using the /nx option to have it run every x number of seconds. For example, this command will list the login users via the w command once every 5 seconds. So right now we're going to end this video, but there are two main things that I think you can learn, and I want you to take a look at these things in the end. So in Linux systems, you want to download files many times from the command terminal or the shell. So what you can do, use these two tools. The one is wget and the other one is curl. Try downloading different files from the web using these two tools, and they're very easy to use, and once you understand, it is very useful in future for the penetration testing purposes.